This video is a demonstration of an autonomic service agent for prefix management in an IP network using the GRASP protocol. It's based on 3 RFCs and it shows 3 instances of the autonomic service agent. They're all in one host because that's easier to video, but in real life they would be in separate machines. The first one is the origin server that originates a pool of IPv6 and IPv4 prefixes. The other two use GRASP to obtain the prefixes they want. So now we're going to start a version of the application. This version is going to be the origin of the prefixes. So once we've read its initial dialogue, we have a few questions to answer, which I won't describe in detail. And then when we get to the final question in a moment, the autonomic service agent will set itself going and we'll see what happens on the screen. Here we go, and we're away. It's starting to tell us what's going on, and now it's thrown up a little window showing us what it's doing in a rather visual form. Now we're going to move that off to the side and start up the second copy of exactly the same program, but this one will not be running as the originator of prefixes. It will be running as what I call a delegator, which consumes prefixes that it obtains from the origin server. Again, we have a little dialog. Tell it something slightly different. It's going to be allocating /64 IPv6 prefixes, and once it gets going, it'll throw up its own little window, and then we'll see what it does. Here we go. It's getting some prefix management parameters. It finds them. It notices that its pool is low. It starts asking the other service agent for spare prefixes, and it got some. Now we're going to start up yet another instance of the same program, also as a delegator or as a recipient of prefixes from the origin. And both the delegators will be pretending to delegate the prefixes down to routers using DHCPv6 prefix delegation in all probability, but that bit isn't implemented here. It's just a demonstration after all. Here goes the third one. It does the same thing as the second one, starts asking for prefixes, gets some prefixes, and once that's well established, I'll tidy up the screen so that you can see the three autonomic service agents working independently of each other, but communicating all these requests and responses using the GRASP protocol. I'm fishing around for the purple one to get that into the right place. And here we go. So you've got the origin server at the right, the 2 delegators at the middle and the left. And they are all talking to each other since they're all peers. When one of them needs some more space, it looks for one of the others using GRASP discovery, makes a request for prefixes using GRASP negotiation, and then sets about delegating the prefixes to imaginary routers. And from time to time, they tell you what they're doing. Either they tell you that they've got a prefix pool, or they've run out of prefixes, that they've assigned prefixes, or that they're asking for more prefixes. And if you watch the video closely and possibly pause it to have a look at the messages before they go up the screen, you will see negotiations taking place between any 2 of these 3 autonomic service agents, and in fact they could be taking place between any number of autonomic service agents in a large autonomic service network. The basic idea here is that a carrier, internet service provider, could use this technology to manage its address pool so that no operators would have to mess about replenishing address pools if they run out, because it would all happen automatically and at a speed probably much, much less than in this demonstration, which is artificially accelerated in order to give you a demonstration. You see a failure case there, no prefix available. That's because one of the agents asked another one for prefixes and it didn't have any. Eventually it will find someone from another agent The total pool of prefixes is pretty large, especially the IPv6 prefix pool, but the agents will, at any given moment in time, maybe only have a small share of the pool, and eventually they will realize that the only thing they can do is ask the origin server. But that doesn't need to be hand-coded. That's just built into the way the algorithm works and the way the programs work. And so the process will now continue indefinitely, except for the very unlikely case that we've exhausted both the IPv4 pool, which is the whole of net 10 in this case, and the IPv6 pool, which is much, much larger. At the moment, it contains thousands of spare prefixes. So you can go to GitHub to find a bit of a write-up about this and to find the Python code if you'd actually like to run it on your own machines or your own network.